Hey everyone, this is Shin, and I'm a student of ECE 5590. This is a software security course, and in this video, I will demonstrate CAPTCHA cracking with machine learning. So this is our table of content. I will briefly go through introduction and talk about the attack mechanism I used, and I will do a brief demonstration, and then I will talk about what I learned from this class and assignment, and finally I will discuss about the defense method and some future research. First, what is CAPTCHA? So CAPTCHA is a challenge response test for website to distinguish the human and the robots. It was very efficiently throughout at start of this century, and it's very widely used, deployed in a lot of websites uh, to prevent the bots from sensitive and damaging actions. For example, batch registration and spamming and online ordering, even attacking the some website. And why we want to attack the captcha challenges is because if we can bypass the captchas, then that will give us some insights on this technique. And also, if we can prove the bots can defeat the captchas, then we prove there are security risks on this security system. And second, because the machine learning is pretty powerful in the recent decade, so I also want to prove the machine learning can effectively like complete those capture challenges. But in this topic, in this video, I only narrow down the topic to the normal captchas, which are like five characters images, like the image on the right. They're like kind of distorted, but humans still can like uh recognize those characters, but the bots will have a hard time to do it, but will prove that that's not the case. All right, so for my attack mechanism and implementation, so first for the data, I found public dataset on the Kaggle. There are 110,000 of the captured images, and I load them to the cache, to the memory to speed up the process, and also I perform some augmentation to the image. This including the color jetting and smaller rotation and etc. And each one image will generate three augmented image in the training dataset. Oh yeah, and for training and testing splitting in my machine learning training is 80/20 and yeah. And for my machine learning setup, my model architecture, I have CNN to extract the visual features and have GRU to like collect the time sequence features. Basically, I treat each characters as one time spot, a time point, stamp, and GRU will like process them sequentially. And finally, we have the decoder to process the features from GRU and pick up the top like uh uh top significant features. And finally, I have the classifier to classify those characters based on the features based on the possibility of each characters and produce the result of these five characters. So for demonstration, my setup of my uh, uh, experiment is first I set up a simulated CAPTCHA server. It will automatically generate a random CAPTCHA image. Um, I set it out locally. I didn't try it on any famous website. The first reason is it's not ethical, and the second reason is uh, most of the websites are using recaptchas, the more modern version of the captchas. So it's kind of hard to find those. And for the attack part, my trained model. So I will use my trained model to predict the characters that generated from the server, and I will also and in the real time, and then I will generate output of the result. All right. So this is my code. So this is a training result, by the way. So it actually reached out a pretty high accuracy, 72% with uh, like 2 hour training. And if we ignore the case, like uppercase or lowercase, but then the accuracy can come to the 89%. And in the test image, you can see they are all successfully like predicted, like produced a correct result. Okay. Um, but uh, but in the so I set up the server. So this server called Captcha Generator is based on Flask, and when it called captchas, captchas, it will return an image, and then I will use my real-time inference to infer that image to a output string. But the only thing I want to mention here is that this accuracy I checked it, it's not that so accurate. You will see it later. Uh, this is because the generation like base is different. My simulated server is from a capture library, but the my training data is from a public data set. But let's see. Yeah. So after I hit enter, this will call the server and generate a new image, and we will get the predict captcha. So yeah, so as you can see, it successfully predict 4 charts out of 5. The last one is wrongly predicted. And let's generate another one. And this one, oh yeah, the last one is also failed to predict, but first 4 are all correct. This one also has 4 correct out of 5. This is a kind of dilemma this model countering. Uh, So yeah, for this one, it's all correct. B for EXJ, and the image is also B for EXJ. Yeah, it can't ensure every single time that it can produce all 5 correct, but you're guaranteed there's at least 3 correct. Oh, this one is also correct. So yeah. Uh, okay, this one the Y X became Y, but yeah. Uh, I think this one can prove partially this model is working, even though there's still a lot of space that require improve, especially when dealing with like this R is it, for him for this model is very hard to predict, and for zero you're always like confused between 0 and O. That should be put into the future works to resolve. Okay. Now, so for this assignment, and what I learned is first, uh, traditional capture methods can be defeated by using the machine learning methods. Even though in my case it didn't that efficiently defeat the captchas, but it still have like half of cases are succeed, right? Um, and yeah, and this also indicates static Chinese response mechanism is not enough for the modern technology. So more advanced captcha is required. That's why we have reCAPTCHA even version 4 right now. Those uh, will be more complex, but I think if we can do more research on that and try to attack the latest captcha will be pretty fun to to see. And also uh and also I feels like to detect the robot and human, it's not like we should not only limit to this challenge only. We should analyze other kind of behaviors to like give uh a simple result. And for some defense methods, so first, as I mentioned, dynamic captures. We need to provide more dynamic challenges instead of a static because static always can be defeated eventually because the technology is keep advancing. And second, we can combine different like analyze to further like detect if this is human or robot. And finally, a captcha should be regularly updated. The method should be uh, ensuring the modern technology won't uh like like bypass it so easily. And yeah, at the same time at the same time we should do more attacks on this kind of security system to help them to improve. Yeah, I think this is also the meanings of this class. Like we need to do some counter to see uh, where we can improve. Okay, and thank you for listening. And if you want to see my work, the GitHub link is here, and this is my reference.